Now, surface tension. Each and every liquid have this characteristic of surface tension. The free surface of the liquid, it implies that the surface of the liquid which one is in contact with air, it behave like a stretched membrane. It always try to decrease its surface area, and that is due to surface tension. Now the definition of surface tension that is given like this: the force exerted by the molecules lying on one side of an imaginary line of unit length on the molecules lying on the other side of the line, which is perpendicular to the line and parallel to the surface, is defined as the surface tension of the liquid. Now, surface tension is given by the equation force per unit length of the imaginary line at the surface. So, force of surface tension, that is T into L. If you want to write the unit of surface tension, then that is Newton per meter. And its dimensional formula that we can prepare as M1 L0 T minus 2. Okay. Now, say why this particular characteristic is there. To understand this thing, consider this figure. This figure is not there in the textbook. Here, this one is for your better understanding. Now see, here between the molecules of the liquid, there are the attractive forces, as well as between the molecules of liquid and air, the attractive forces are there. Now see, suppose we think about any molecule which one is inside the liquid. Now see, between molecules there is the attractive force, means one molecule attract another one. But this attractive force is not up to large distance. This attractive force that will be up to certain small distance. Suppose that distance is R0, up to which the molecule can exert the attractive force, right? Now, suppose we consider one molecule somewhere here, and by taking this molecule as a center, if we imagine a sphere, this is imaginary sphere, having radius equal to R0, where R0, that is the distance up to which the molecule exert the attractive force. હવે આ જે સ્ફિયર આપણે કન્સિડર કર્યો, આ સ્ફિયરની અંદર બહુ જ બધા મોલેક્યુલ્સ છે. Now all these molecules which are residing in this imaginary sphere are either at a distance R0 or less than that from the central molecule or molecule at the center. It implies that the attractive forces on this molecule which one is at the center from all other molecules inside the sphere will be there, and these forces will be in all the directions as shown in this figure. So net force will be 0. Clear to all of you? Now suppose we consider the layer of the liquid having thickness equal to R0 at the surface of the liquid. Now from the free surface, if we consider again one molecule which one is at a distance R0 by 2. From the free surface, this molecule is at R0 by 2 inside the liquid. then some part of this particular sphere considered by taking this molecule as a center will be outside the liquid. That will be outside the liquid. Now, due to liquid molecules which are residing in this dark part of the sphere, will exert some resultant force on this molecule in downward direction. All those molecules which are in this part of the sphere which is represented by the lines will be balanced. And now the molecules which are in this empty space are molecules of air, will exert some attractive force on this considered molecule in upward direction. But the attractive force between like molecules that will be greater than the molecules which are unlike. એટલે કે હવે પોઝિશન એવી થશે અહીંયા આગળ કે આ જે મોલિક્યુલ આપણે કન્સિડર કર્યો એની ઉપર net force that will be in downward direction. Net force will be in downward direction. હવે જેમ જેમ આપણે આ લેયરમાં ઉપર જતા જઈશું, and suppose we consider the molecule which one is exactly at the surface, then by taking this molecule as a center, if we imagine a sphere, then half sphere will be filled with liquid and half sphere will be empty one. It implies that the maximum downward force that will be on the molecules which are on the surface. Clear to all of you? Now it is clear each and every molecule which one is at the free surface of the liquid experience the resultant downward force. Now, if some molecules are able to move in downward direction under the effect of this force, then on the surface between the molecules parallel to the surface, the attractive force will present. And now on the surface, if we imagine a line, that is also imaginary one. Now concentrate on definition. Now on the free surface, if we imagine a line, which one is imaginary one, having length equal to L, then the molecules which are on one side of the line will exert the attractive force on the molecules which are on other side of the line. And this particular force is parallel to the surface, but perpendicular to this imaginary line. So this force per unit length of this imaginary line, that is called surface tension. Now repeat the definition. The force exerted by the molecules lying on one side of an imaginary line of unit length on the molecules lying on the other side of the line, which is perpendicular to this line and parallel to the surface, that is defined as the surface tension of the liquid. Clear to all of you? Now, if we think about this type of imaginary line having unit length at the edge of this surface, then for that particular line, only one side the molecules are there. On other side, the molecules are not there. So, the net force at the edge of the surface, that will be parallel to the surface but inward, and due to that each and every free surface of the liquid have tendency to decrease its surface area. It implies that we can say each and every free surface of the liquid behave like a stretched membrane of rubber. Clear to all of you?